Hello, everyone. Welcome back to this live series on data science with Python by PamTen. So, till now, we've learned all the fundamentals of Python, and then we've also learned about object oriented programming, and then we've done some data manipulation or data munging with a library called as Pandas. And in this session, we'll learn how to do data visualization with a library known as Seaborn. And since this is a live session, you can go ahead and put in your queries or any suggestions or feedback in the chat section, and I shall take them up. Let me just check if the live session is functioning properly. Let me see if the audio and video are proper. Okay, seems like I can see the video and I can also hear the video audio properly. Okay, since everything is good, we shall go ahead and start our live session. So this is the agenda for today. With the help of this library called as Seaborn, we'll be making all of these different types of charts. We'll start off with something called as a line plot. Then going ahead, we'll work with bar plots. Following ahead, we'll make scatter plots, and finally, we'll work with box plots. So we have this particular thing called as a line plot, and what we do is we import a library called as cborn and we give it an alias, and by convention we give it the alias of SNS. So we type in import cborn as SNS, and then this library cborn is built on top of matplotlib, and since this is built on top of matplotlib, we would also require to import this. So we'll type from matplotlib import pyplot as plt. So matplotlib is our library, and from matplotlib we are importing another submodule called as pyplot, and we are giving it a name or alias as plt. So we have cborn, we have pyplot. Now that we have both of this, what we can do is this library, Seaborn, has some inbuilt datasets inside it. So once we import this library, we can use those datasets which are already present in this library. So one such dataset is the flights dataset. So we'll use this method called as load dataset. So we'll type in sns.load dataset and given the name of the dataset, which is flights, and we are storing it in a new object and we are calling that object as flight. So you can give it whatever name you want on the left hand side over here. And since this is basically the flights dataset, I've made it simple and I've called the object as flights. Then we'll go ahead and look at the first five records of this. So when we print out flights.head, you would be able to see the first five records of this dataset. So again, if you have watched the previous sessions, you would know what the head and tail methods are. So now that we understand what exactly is this data set, we can go ahead and make a line plot. So this particular data set would have certain columns, and one such column is the year and another column is the passengers. So this data set basically tells us how the passengers or the count of passengers has been varying across years. So seems like we have data here from the year 1950 to 1960, and you see that the passengers who have been on the flights are steadily increasing throughout the years. So in this 10-year period over here, you'll see that in 1950 there were around 120 or 130 passengers, and in 1960 there were around close to 450 or 480 passengers. So now that we have looked at how this library works, we can go to Google Colab and actually write the code ourselves. I have opened up Google Colab over here. And also, I'd like to remind you guys that since this is a live session, you guys can put in your questions, or you guys can, if you want to share any sort of feedback, you can do that in the chat section. I will be checking the chat section while I'm giving this lesson. So now, what we'll do is we'll implement the code that we've seen previously. I'll type import cborn as SNS, and this is the library that we shall be importing. Once we import this library, we will also need another library called as matplotlib. So from matplotlib, I would want to import a submodule called as pyplot. So I shall type from matplotlib import pyplot. I'll give this an alias of PLT. So these are the two libraries that we have imported. Once that this is done, I can finally go ahead and load the dataset. So this dataset is part of the SNS or Seaborn library. So I will give SNS dot, I will type load dataset, and I will give in the name of the dataset, which is flights. I'll store this in a new data, new variable called as data, and I can go ahead and have a glance at the head of this. So I'll type data dot head. Let's see what would be the result. And as you can see, the years here go from 1949. So it starts from 1949. So January of 1949, there were 112 passengers. February of 1949, 118. So you see that the number of passengers are steadily increasing. This is the trend that we actually see over here. And if I would want to maybe find out the minimum and maximum values of the number of passengers, what I can do is I can just type minimum of, I will take in the data, and then I shall give in the column name. So the column name would be passengers. And you shall see that the minimum number of passengers was 104. Let's also find out the maximum number of passengers. So it seems like the maximum number of passengers were 622. And also let's look at the range of the year. So let's type in min. Instead of passengers, I will type in year. So the minimum year is 1949. Let's also have a glance at the maximum year. I'll type in max, and you shall see that the maximum year is 1960. So we have the data from 1949 going on till 1960. So we have looked at this. Now it's time to actually make the beautiful plots. So here, since I would want to make a line plot, I will type SNS dot line plot. You will see that we have the auto suggestions on over here, and that will actually give me the suggestion. Now, I would want to map something onto the x-axis and something onto the y-axis. So I'll type x equals to, and I shall map the year column onto the x-axis. So x equals year, and I'll have to map something onto the y-axis. So I shall map the number of passengers in the y column. So here I shall type in passengers, and I'll have plt dot show. So I'm just showing this graph over here. Now, along with this, so the error we are getting because we've given the column names, but this method line plot doesn't really know what data set these columns are part of. So I would need to give in another parameter called as data, and the name of the data set is also data. So I'll have this, and you shall see that we have successfully made this really pretty graph. And this gives us really insightful information. So here you see that there is a upward trajectory starting from 1950 to 1960. You see that the number of passengers are steadily increasing. Now, once that we've made this basic graph, let's see what else can we do over here. So we have these different parameters. So if I were to include another column into this graph, and I were to vary the colors of these lines on the basis of that column, I can use the hue parameter. So here, hue basically stands for the color of these lines. So I can set the color of these lines on the basis of a new column, and that is what I'm doing over here. So I'm setting the color of all of these lines on the basis of the month column, and here you shall see that January month shall have a different color, February will have a different color going on till December. So here, from this, we can basically figure out that these bluish or greenish color lines, so that is when you've had the most number of passengers. So here, that would be the month of maybe July, August, September. So it seems that July, August, and September is when you have most number of passengers traveling. And here, if you look at this, so this seems to be pink, maroon, purple, so probably sometime over here, October, November, and December seem to be the lean periods where you don't really have a lot of people traveling. And here, so this was the hue parameter that we've used to have these different colors for these lines. Instead of hue, we can also have other parameters. So we have something called as style, size, and markers. So we'll also go ahead and work with these different parameters. Let's go back to Google Colab and make this really pretty line plot. So what we have to do now is I'll again go ahead and make the basic plot. I'll type SNS dot line plot onto the x-axis. I would have to map the year column. And once this is done, I would have to map something onto the y column. So I will pass in the number of passengers onto the y column. I'll have passengers and data is obviously data. This is where I'll give in a new parameter. I'll have hue and I am mapping the month column onto the hue attribute and I will type in plt dot show. Let's just wait. So here you see that we've made this really pretty plot where you have different colors for all of these lines, and each line is basically representing a different month, and also each month has a different color. Now we had also looked at certain other parameters in the presentation. Let's also add those. So here we have hue. I'll type in SNS dot line plot. On the x-axis, we obviously have the year column, and then on the y-axis, we shall have the passengers column. Then we need something on data, so data would equal to data, and then I will have style. So there'll be a different style for each line. So style again would be dependent on the month column. Let's see how would this look like. So here you see that there is a different style for each line. So Jan is a solid line. For February, you see that it is dashed lines, but the length of the dashes over here decreases. And then you have some sort of pattern for August. Similarly, you have a different sort of pattern for December and so on. Now, I'll probably change this up a bit. I'll also add the hue parameter so that it'll be easier to distinguish. So I'll set hue equals month, and you shall see that this looks better. Now, there is also another parameter which is size. So I can vary the size of each of these lines. Again, the size would depend on the month column. Here you shall see that January has the thickest line and December has the minimum. It has the thinnest line. So here it would seem that January and then this would be February. So January and February are the months where you have least number of passengers. And then these are your blue colored and dashed lines. So again, this seems to be September and August when you have most number of passengers. So this is a really interesting observation, isn't it? Now I can also have markers on top of this. So here I'll just type in markers equal to, I'll just add true and let's see what do we get. So here you shall see that I have these different markers. So for January, you have a solid circle. For February, you have a cross. For March, you have a solid square and so on. Now, maybe instead of this style, so I'll just remove the style and I'll just have the markers and let's see how would this actually look. Okay, so it seems like we can't really have markers without the style. So that is something interesting that we've learned. So these are the different types of parameters that we can work with when it comes to line plot. So this was really fun, wasn't it? Going ahead, we'll also work with another type of a chart, which is known as a bar plot. So bar plot helps us to compare frequencies. And again, we'll be using the flights dataset over here. And then the command is pretty much the same. Instead of line plot, I'll be typing SNS dot bar plot. And again, year column goes onto the x-axis, passengers column goes onto the y-axis. And here we see that the passengers are slowly increasing across the years. Let's go ahead and make this really pretty graph. I'll go back here and I shall type SNS dot bar plot onto the x-axis. I would have to map the year column, and onto the y-axis, I would have to map the passengers column. Data is obviously data, and I would have to show this. So I'll type in plt dot show, and you shall see that I have created this really pretty graph. Now, if I would want these bars to have different colors, I can do something similar. So maybe I'd want the colors to be dependent on the month column. So I can just set hue is equal to month. Now, this is really interesting, isn't it? So here, what you have is for every year, you have a bar for each month. So here you have 12 bars of different colors for the year 1949. Similarly, here you have 12 bars for each month of the year and 1960. So this is something really interesting. Now, instead of this, maybe if I wanted a palette, so there are some predefined color palettes. So there is a color palette called as Rocket. So here, this is how this color palette will look like. This is interesting, isn't it? Similarly, there is another color palette called as VLAG. Let me type in VLAG, and here you shall see that this is how VLAG will look like. So this is interesting. Let's go ahead and see what else can we do. So next up is scatterplot, and scatterplot is normally used to understand or visualize two numerical columns. So here on the x-axis, we are mapping a numerical column. Also on the, so this was y-axis, and also on the x-axis, we are mapping a numerical column. So this time, instead of the flights data set, we are using a new data set called as Iris. So this is a really popular data set called as the Iris data set, which has around 150 records. And this comprises of 150 records of three different species of the iris flower. And it has features such as the sepal length, petal length, sepal width, and sepal width of the iris flower. Now we'll go ahead and make some really pretty visualizations for this. I'll go back to Google Colab and I shall make a scatter plot. I will type in sns dot scatter plot. Before this, I would have to load the dataset. So I will type sns dot load dataset. Inside this, I will give in the name of the dataset, which would be iris. I will store this in a new object, call this as iris, and I would want to have a glance at the first 5 records. I will use the head method and I will print it out. And this is how it looks like. So there are 150 records. Since we are just looking at the head of it, we can only see the first 5 records. So we have sepal length, sepal width, petal width, and species. Now, there would be 3 different species. So we have Setosa, versicolor, and virginica, around 50 species of each of these. Now, I'd want to understand how would the sepal length and petal length vary for these 3 different species. So let's actually try to do that. Let me get a new code cell over here. So I'll go ahead, insert code cell. Here, what I can do is I can type in sns dot scatterplot. On to the x-axis, I would want sepal length. I shall type sepal underscore length. Similarly, for the y-axis, I will need petal length. I'll have petal underscore length, and the data is coming from the iris dataset, and I can just go ahead and show this out. So I'll type in plt.show and let's have a look at the result. So this is how it will look like. Well, we can't really tell much about this, right? So this basically tells us that if sepal length increases, the petal length would also increase. There's sort of a linear relationship between these two columns, but I'd want to learn more. This is where I shall again use the hue parameter. I'll set hue to be equal to the species column, and let's look at this. So here you shall see that the Setosa species is at the bottom and Virginica species is at the top. This is a really interesting observation. So this would tell us that out of the three species, this Setosa species has the lowest sepal length and petal length, and Virginica species has the highest petal length and petal length and sepal length. Now that's a really interesting observation. And now let's go ahead and see what else is there. See, we also have a box plot. This time we are using a new dataset called as penguins, and this is about the different species of penguins. So you have Adley, Chinstrap, and Gentoo. And this time we are making a box plot. So when you're working with a box plot, normally we map a categorical column onto the x-axis and a numerical column onto the y-axis because it helps us to compare the mean values or median values for categorical columns. So here we are comparing the bill length of these three different species of the penguins. So here you have Adley, Chinstrap, Gentoo mapped onto the x-axis, and we can clearly see that for Chinstrap species, they have the highest mean or median bill length, and Adley species over here will have the minimum bill length. Now that we've understood this, let's go back and work with this. Again, I would want to insert a new cell, insert new code cell, and after this, let me insert a couple of code cells over here. I would have to load the data set. So I will type sns dot load, and then name of the data set would be penguins. I shall store this in a variable called as penguins, and I shall have a glance at this. I will type penguins dot head, and this is what we have. So you have the species, you have the island, and you have all of these different features. So bill length, which is in millimeters, bill depth, which is in millimeters, you have the flipper length, body mass, and then the sex of the penguin. Now, let's actually analyze this data set a bit. So what I'd want to do is I'd want to have a glance at the different species of this. So I have something called as value counts. I'll first give in the name of the dataset, which would be penguins, and I would have to select the species column, and from the species column I will basically check the value counts of each category. So here you see that in this entire data set there are 152 species of Adley, 124 species of Gentoo, and 68 species of Chinstrap. Similarly, I'd want to see where are these species actually present. So I have this island column. I'll do something similar. I'll type in penguins, given the name of the column, which would be island. I shall use the method, which would be value counts, and then hit enter. Again, so you see that there are 168 penguins on the island Bisco, 124 islands on the Dream Island, and 52 penguins on the Togosan Island. That is really interesting information. Now, what I'd want to do is, with respect to the species column, I'd want to understand how would the bill length vary, and this is where I shall use something called as the box plot. I'll type sns dot box plot. I will have the categorical column, which is species mapped onto the x-axis. I shall type species, x is equal to species, and then I would need the bill length. Let me paste it over here. So I have the bill length, and then the data is coming from the penguins data set. Let me go ahead and print this out over here, plt.show. Let's have a glance at the result. And here, this is what we had actually seen. And again, I'd want to change the colors of these species. So I shall set the hue to be equal to SPECIES. And here you shall see that I have successfully changed the color of all of these three boxes with the help of the hue parameter. So this was really fun, wasn't it? So this is how we can use the Seaborn library and make these really pretty visualizations. So if you'd want to make more such charts, you can go ahead and look at the Seaborn documentation, and you can make all of these. So thank you very much. And if you have learned something valuable from this video, do hit the like button. And if you'd want to share it with your friends, we'd appreciate it. And also do subscribe to our channel. Thank you very much.